All right, so before we get started, I'd like to give you a little bit of background. The title of this session is The Introduction to the IfM, or the Institute for Manufacturing, and the Role of Manufacturing in Sustainability. So through this presentation, we're going to find out what role manufacturing can actually play in sustainability. Professor Steve Evans is the director of the Institute for Manufacturing at the University of Cambridge. He is a partner of the Polyurethane Foam Upcycling Technology Development Project. He's also a director of research in industrial sustainability at the same university, and he leads research that seeks to deliver knowledge concerning sustainable change at scale. He's spent over 15 years in the industry and has over 30 years of academic experience, which includes working collaboratively around the globe. So without further ado, I'd like to invite Professor Steve Evans to present on the topic of the role of manufacturing in sustainability. Professor Steve, the stage is all yours. Thank you.
Thank you, and good afternoon, everyone. I hope you can hear me.
Yes, we can hear you.
Excellent, that's a good start. I also hope that my smile is as good as Banks. That was fantastic and brightened my day already, and it is very early in the UK. So thank you for the promotion. I'm not the director of the Institute, that's my boss. I'm director of one of the research centers in the Institute. So I'm going to explain, starting by talking about what the Institute for Manufacturing does at the University of Cambridge, and then move towards our role and our knowledge in this project area of circular economy. So we call it the IfM for short. It's far too long, Institute for Manufacturing, and it's part of the Department of Engineering at the University of Cambridge. I will assume that you've heard of the University of Cambridge, but you may not know that the Department of Engineering is by far the biggest department. So the University of Cambridge is actually a massive problem-solving space. You may also know that we generate a lot of startup companies and inform governments and industry globally about leading practice. And the Institute for Manufacturing is part of that Department of Engineering and follows that same routine. So we do three things. We do research. You would expect us to do that as a university. We do a lot of education for young people, but also direct for business. And we have our own separate consultancy organization that delivers that latest research thinking as education to businesses and to governments. So yesterday, for example, I was part of teaching some civil servants from the DBT, from the department that Ben is part of, about future policy challenges. We're also incredibly close to practice. And I think it's important to understand that as researchers, we're interested in solving practical problems, not solving problems that might arise in 2070. So my colleagues, myself, and the team at the Center for Industrial Sustainability ask questions about what works and what doesn't work. These are incredibly practical questions, but they're not easy to answer. So yes, I've got colleagues who are inventing new materials and doing fantastic science in laboratories, but about the same number of colleagues spend time in organizations helping those organizations get better at what they do. So we interact with other universities globally, with industry globally, and with governments. So what does IfM do? A lot of research across many research centers. That's those lovely colors at the top. I'll explain that a little bit more. We spend a lot of time on education and on our knowledge transfer. So this is the ecosystem of the Institute for Manufacturing. Each of the 18 research centers, and the one that I lead happens to be in the center at the top. It doesn't mean it's more important or anything. It's just luck in the graphic. So we have 4 research centers that are focused around the detail of manufacturing processes. So those are laboratories. You can come into our building and go into places that looks at the use of light in manufacturing. That's industrial photonics. The next thing, we have research centers that look at how, for example, we use new availability of digital information, data, to organize and operate factories and supply chains in new and interesting ways. On the right-hand side of manufacturing systems, you see a reference to asset management. That's actually relevant for today's conversation. Asset management is about how we use data to track high-value assets. And traditionally, that has been highly relevant to companies like Rolls-Royce, who make jet engines, and they need to know exactly what is where to maintain and repair those. But as we move into a circular economy where we're doing the same thing, we're tracking the goods that we send out into the world, we need to know where they are, what condition they're in, what's been happening to them, so that when they return, we can make a calculation about whether we refurbish it, we tidy it up, clean it up a little, and then it's still available, as high performing as it is when it's first made, to go back out to future customers, or whether it's time to begin to recycle that particular mattress. So that particular research center is focused on the use of digital to manage assets. And I could carry on. I could pick randomly any of the other research centers, and I'll make a point about the relevance of those centers to the particular problem that we're talking about today. But let's go into the world of industrial sustainability. In particular, what do we study? And I like to understand the size and the shape of the problem. And I hope I can be clear. By 2050, the world has to be very different. We already know that manufacturing causes a large part of many of our environmental problems. But by 2050, we'd also like to increase the advantages that the world has gained by the success of manufacturing. When I was small, a long time ago now, my mother took 7 or 8 hours a day, 1 day a week, to wash the family's clothes. And she had a machine, but it was very crude compared to today's modern machines. Manufacturing has reduced the price of those machines so that after this event, I'm going to be putting my shirt in the washing machine along with lots of other things. And an hour later, it will come out and I will put hardly any of my own effort into washing those clothes. That doesn't come from the inventor of washing machines. That comes from the world of manufacturing, who make those washing machines available at $300 rather than $3,000 or $30,000. And we want to continue to deliver that value to the world. So we expect by 2050 to treble or quadruple the output of factories. We cannot do that with the current system. We're already breaking the planet. So if we are to quadruple in value and output, we also have to reduce 80% less to produce and emit 80% less greenhouse gases and halve the resources that we're growing and mining from the planet. That's the size of the problem that we study. And as we study that problem in practice, we deliver knowledge, which we then turn into tools and methods that other people can use to solve similar problems. And that's what we've been doing in this project with Nornon and AIT. So we've studied and worked on the problem of how to make the circular economy practical for some time. And we're bringing that knowledge to the benefit of this particular project, and we've enjoyed working with everyone as they're trying to solve their local and special practical problems. I just want to give a minute to the three main sets of research that we do. The one that I'm not going to refer very much to is radical efficiency. So we study how factories can become 300% more efficient in the way they use energy, water, and materials. So not 3% or even 30, but 300. And that's what we mean by radical efficiency. And we're not talking about labor efficiency. We want to become efficient in the way that we convert energy into end product, whether that product is a piece of furniture or clothing or food or a car. But that's not the subject of today. Today, we're going to be using knowledge from our two sets of research on value innovation and on system transformation. Value innovation asks the question, how should we be delivering value to our customers and other stakeholders in the future? And with Non-Non, you can already hear that they want to deliver value by connecting their knowledge of matrices, the materials and technology and logistics around matrices. They want to connect that knowledge to the value that you get as a customer. And to do that, they want to just stop selling mattresses and make them available in what we would call a use model, a pay-for-use model. And the really good thing about that is that at the end of your particular use, that mattress becomes available again to Non-Non who have the right knowledge about what to do with it. And if we can connect knowledge and value together very well, in the long run, that's going to make it cheaper for customers and better for the planet, because we will not be throwing away material that Non-Non knows how to extract value from. We as individual citizens don't know how to extract value from the things that we are tired of. But the people who made them do. And that business model, that value innovation connects that knowledge with the delivery of value. And we study that with great care. And the other thing we study, and this is the biggest problem of all, is transforming what is often called a linear industrial system into a new form of system. Here, that new form is circular. So what are the challenges in actually doing it? It's one of them, and it's a fairly obvious one, is that it's complex, very complex, to be the pioneer, to be the first. You're asking customers to think differently. People haven't traditionally had a pay-for-use model for books or for tables, for example. So you're asking customers to be different, but you're also asking the system of delivery to be different. Historically, when we've got tired of a product, we've engaged with the waste sector to manage the end of life of that product. Now we're engaging again with the organization that made the product and with logistics to get it back. And that's one example of a part of building a circular system. If we get those things right, though, we build industrial systems that deliver fantastic value to customers and are incredibly resilient. So if you are, imagine you're a company that rents rather than sells. One of the nice things is if you have a bad month for sales, you still have income for all of your fleet of mattresses that are out there. So it turns our businesses into financially resilient things. Now there's a cash problem with that. We know how to finance those things, but that's an example of the type of mini challenge that exists when we're changing the system towards a circular system. And we study that. We've brought that knowledge to Nornon and AIT and shared with them some of the things that we've learned, which have helped come up with the pioneering solutions that you're going to learn more about today. And now I'd like to spend my last couple of minutes having some fun and talking about the future, because the future is going to be very different. If we are going to deliver value to ever more people, and yet do that within the limits of the planet, the industrial system is going to look very different to the way it is today. Well, how quickly can that happen? And I found this graphic really helpful. So Ben will be happy that I'm advertising the contents of the UK. This is the daily share of coal in the UK electricity generating industry. And when the color is really black, that means that most of the energy on that day was coming from coal. When it's dark gray, still most of the energy from coal, but with a good amount from gas. When it's gray and light gray, mainly gas with less coal and a bit of renewable. Light gray is almost entirely gas with some renewable, and blue, no gas, no coal. And look how quick it happened. The worst year in this picture was 2013 and the best year was 2020. We can shift systems as large and dominant as our energy system in as short as 7 years. And I want to encourage people in the room to believe that the world always, in the short term, changes slower than we wish for. We'd like things to be better by Christmas, and it tends not to happen. But in the long term, it tends to change faster than we expect it to. And so I believe that what you're hearing today is a pioneer. But if we did this presentation in 20 years' time, everybody would be saying, oh, it's boring. We've been doing that forever. We quickly begin to live in the new world. Now, another advert for the UK government, a small part of government, is called the Government Office for Science. And in 2012, they asked a small number of us to write a report on the future of manufacturing out to 2050. And that report is available online. I think it's actually still very interesting, even if it's 10 years out of date. But when we finished, I wrote myself a slide. Everything that's written in green here, I wrote 10 years ago. The red, I've altered just for you today. And one of the most interesting things that we observed in 2012 was a prediction that from 2020 to 2040, the middle of the three waves of change, from 2020 to 2040, business would be characterized by disruption. We expect to go from one type of shock, and rather than then have 5 years of stability before the next shock, or 15 years before the next shock, we believe that the next 20 years will be 3 to 5 shocks. So it's actually quite challenging to work out how you invest into your own industrial system during that period of multiple disruptions, and resilience becomes ever more important. One way to deliver resilience is to have a circular economy. So although what you're seeing today might sound like we're doing it for wonderfully green and save the planet reasons, I'm going to suggest that everything that you're hearing today is actually incredibly sensible, modern business for this decade and the next decade. We need to become circular and resilient because those things are going to help us manage the economic conditions of these 20 years. So I've said my piece. I'm going to say thank you, and I'm going to make a request of the room. Everybody looked very happy. I hope you're still happy after listening to some of that. It's fantastic to be part of the project, but I would like to encourage you all, please be efficient and please get ready for this massive shift and listen to this project because it's got insights into that important shift that's happening to all of us. Thank you.